In our classes, we have each observed a high number of classmates texting throughout each session. As a group, we were curious to see if texting had a negative effect on grades. We also wanted to know if the amount of text a person sends has any impact on their grades as well. Our null hypothesis was that mu1, our light texters, would have the same GPA as our mu2, our heavy texters. Our alternative hypothesis was that our light texters would have a greater GPA than our heavy texters. After collecting responses to our survey, we divided our sample into two groups. The first group, light texters, was defined as less than 10 texts per day during class, and our second group, heavy texters, was defined as 10 or more texts sent per day in class. Below, we have included the sample size, average GPA, and the standard deviation for both groups.
This graph represents GPA versus number of texts sent. The slope of this line is negative 0.0047 and shows that there is a negative linear relationship between these two variables. The correlation coefficient, or R, is negative 0.1077, showing a weak negative relationship. Since R is so close to 0, then it is considered not significantly different from 0. The coefficient of determination shows an explained variance of approximately only 1%, leaving the coefficient of non-determination, or unexplained variance, as approximately 99%. This graph represents GPA versus age. The slope of this line is 0.0075 and shows that there is a positive linear relationship between these two variables. The correlation coefficient is 0.1233, showing a weak positive relationship. Since R is close to 0, then it is considered not significantly different from 0. The coefficient of determination shows an explained variance of approximately 1.5%, leaving the coefficient of non-determination, or unexplained variance, of approximately 98.5%.
This regression analysis was used to find out if a model could be created from the data to predict a student's GPA based on their age and the number of texts they send per day. The coefficients report the influence that each variable would have on the resulting GPA. When other variables are held constant, GPA rises by 0.0063 points per every year older someone is. The number of texts sent influences the equation in the opposite direction. When other variables are held constant in this case, GPA is lowered by 0.00373 points for every text sent. Based on the coefficients for each variable, age actually had a larger influence than text, but both were extremely small. Further problems with the model arise when looking at the graph of residual versus fits. The data does not fall randomly across the graph, and instead fans out at the top, with very few points towards the bottom of the graph. Decision and summary. Our decision for the hypothesis was to not reject the null. There was not enough evidence to support the claim that people who text heavily in class have a lower average GPA than those who do not. Our t-test for a difference in means had a test statistic of 0.82, well below the critical value for alpha equals 0.05, which was 1.984. The p-value for the test was 0.20, well above the 0.05 cutoff point that would have allowed us to reject the null hypothesis.
Our study falls short when we analyze the probability that everyone in the study has an equal and random chance of being selected. Since our study was taken online, this limits the population to college students with access to computers, or who have a link to our survey, as opposed to the population we were looking for with all college students. If the assumption is that the population is of all college students, our sample would not be able to be applied to the entire population because of our biases. There would need to be a larger oversight and a sample of a lot more people to be able to confidently assume that the results are the same or fairly similar for all college students. There were a number of weak points with our study, the first of which being the study that was done was correlational in nature, and thus causality between the two variables cannot be determined. For example, there is not a way to verify that the study's results were not significantly influenced by other variables such as sampling bias, measurement bias, or even lurking variables. Sample bias. Since the sampling was taken from college students that are also taking Statistics 244, which is a basic class needed for a variety of majors, there's not an even representation of age in our study. The sample was also limited to the number of people who voluntarily took the survey. This could significantly bias towards people who are on D2L taking surveys instead of busy texting. Measurement bias. One form of measurement bias is the fact that the estimates of both amount of text sent during class per day and the student's GPA were self-reported. The expectation was that the students might underreport the number of texts they sent during class and overreport their GPA. Lurking variables. There are also many lurking variables that could have impacted our study. With our design and implementation of the study, there was no way to account for every variable. Some lurking variables may include ability, which means that more academically able students would tend to have a higher GPA without taking the amount of they text into consideration. The conclusion to our study. We found a very weak and not statistically significant correlation between students' GPA and the number of texts they sent during class.